Okay, so in each of these equations, no, well, each of these graphs, excuse me, we want to find the equation slope and y-intercept for each line. Let's start with the y-intercepts. Well, that's when our lines cross the y-axis, right? And the y-axis here is the vertical line. So in the first case, it's nice and easy. The y-axis here, y-intercept here is what? Well, the y-intercept is this point 3. That's where it crosses the y-axis. Okay, so we've got that in the first one. In the second one, I'll go down here. It's also easy because our point right here is of equal height to the other points. And that's just what? Well, if the height's always at 9, now the y-intercept is equal to 9, right? This point is 0, 9. Now D is interesting because we have this vertical line, and that means, well, if it's vertical, it's parallel to the y-axis and they'll never meet. So here, actually, there's no y-intercept, right? If your line's parallel to the y-axis, that means they'll never meet. If they'll never meet, there'll never be a y-intercept. There is an x-intercept down here at 6, 0. That is the x-intercept, or the location where our line crosses the x-axis. And over here, this line is, in part C, going back here, this line is parallel to the x-axis and thus has no x-intercept, right? It's a nice feature of this line. No x-intercept. Now, B is difficult. We can't see where the line crosses the y-intercept. We know it will, but we'll get back to that one. Because we've taken care of the y-intercepts for each. Now we're looking at slope. Well, in the first one, right, slope is just a measure of your rate of change. How much is your y value changing in relation to your x value? So here I go to, from the 2 points they give us, I go up 3 and then over 6. So our slope is 3 over 6, right? Change in y over change in x. That's 1/2. So for part A, we have an equation, right? Well, we're going to use the y equals mx plus b format, or slope-intercept format. It's just called that because we literally just write in the slope, 1/2 in this case, times x, and then add the y-intercept. So it's called slope-intercept form because all we need is the slope and the y-intercept to write the equation. Now, in part C, I'll jump back to that one. In part C, y is equal to what? Well, what's the slope here? Well, the height's never changing, right? If you look at these 2 points, they have the same second value there. And that means the height's equal. And if the height's equal, this creates an interesting scenario. Our slope, remember, is just your change in y over your change in x, right? How much is the height changing for your position left and right? But if the height's never changing and you try to subtract points to find the height difference, what's going to happen? Well, that ratio becomes 0, right? Because 9 minus 9 is 0. In this case, the x values are 8 and 2, so I can subtract the x values. So here I see that the height doesn't change at all for 6 spaces on the x-axis, and thus will never change at all. And 0 divided by 6 is 0. So here in C, our equation is y equals 0x plus our y-intercept, which is 9, but that just equals 9. So often we write these equations for horizontal lines as just y equals 9. And that might make some sense there to you because, right, if this line is always at a height of 9, and that's really its major defining characteristic, then we just define it by its height, where y equals 9. That's what this line is. D is kind of the reverse of that concept. Here, the height's always changing. It's always different, right? The line's going up and down. But the x values are never changing. So here we just call it by its x value. So in part D, this is equal to what? Well, oops, fix this. Well, in part D, right, x is equal to 6. Because in that one, right, the only thing consistent amongst all the points is that x is 6. And here the slope is undefined, which is, I think, fun to think about because here what's happening is when you try and find slope, you're going to subtract different y values, 10 minus 3, but now the x values are equal, and that means your denominator will always have a 0 in it, which means what? Well, here if we have 10 minus 3, that's 7, over 6 minus 6, that means over 0. And that means we would have to divide by 0. And dividing by 0, right, that's undefined. So here we say that the slope is undefined because if we try to solve for it, we would have to end up dividing by 0. Now there is one part left, b. We're going to kind of combine our ideas so far to solve it. And first we can define slope. Well, I go up from this point, right, all the way up here, and then over. How far did I just travel? Well, I went up 12, not 6, right? Went from 6 to 18. That's up 12 units. And then back 4, not 2, because, well, right, again, the increments here are by 2. So that means our slope is what? Well, 12 over negative 4, or negative 3. And that means we can think of it as down 3 and over 1 to the right, or we can go up 3 and back 1. And I just did it myself, but if I went down 3, I think it was taking 3 increments, that's actually 6. Right, so be careful on this one because we need to keep following the slope until we cross the y-axis. We want to find that y-intercept. Now I realize that the distance, we're at this point, let's say right here, to reach the y-intercept, I have to close this gap. And that gap is 2 units, right? Because the increments are going up by 2 here. So if I go up 3 and back 1, that's not far enough. I have to go up 3 again and back 1 to reach the y-axis. Or I have to go a total of up on 6 on the y-axis and back 2. And 6 over negative 2, it is still negative 3, so we're keeping the slope constant. But where would that be? Well, here this point is 218. To go up 6 would bring us to 24, or a height of 24, and then back 2 would bring us to 0, or 0, 24, is that y-intercept point. So that means the y-intercept would just be 24. And again, all I'm saying is if, I'll draw it over here, if you're at this point 218, right, and you want to cross the y-axis over here, well, right, this gap between the point you're at and the y-axis is 2, so you need to go over 2, but in order to do that, you also have to go up 6 to keep the slope consistent. So we go up 6, right, and back over 2 to the y-intercept here. And that point, right, if you think about it, we add 6 to 18 to go up 6, delta y equals 6, and then delta x equals negative 2. And that reaches the y-intercept. Up 6 is bringing us to 24, and we have our last equation. So b, right, well, b equals what? Y equals negative 3x plus 24. All right, hope that helped.